Right, let's look and find the limit of the difference quotient as h approaches 0. And we've got this function over here, 3 over x. First thing I want to do is I want to make sure I know what f of x plus h is. This one's pretty simple because we don't have to do any extra distributing or foiling out. That's just our f of x plus h. Now we got to plug in 3 over x plus h minus 3 over x all over h. Now I'm going to manipulate this outside of the limit notation just to give me a little bit more space to work, because when we have two fractions subtracted like that, we need common denominators. So I'm going to multiply the right by x plus h over x plus h, and the left by x over x. So this is going to become 3x minus 3x minus, I'm going to distribute this negative 3 to both terms. So minus 3x minus 3h all over x times x plus h. And another thing that's important is that when I'm dividing fractions by another value, that would be the same thing as multiplying by the reciprocal. So I'd be multiplying by 1 over h, right? Because this is h over 1. So multiplying by the reciprocal, that means this h is going to get put in the denominator with this other stuff. So I'm just going to put that there right now. So now we can simplify. I've got 3x and a minus 3x. Boom, boom. And then, now that I got rid of those x's, I just have a negative 3h up in the numerator. Well, this h and this h are going to cancel each other out, and we got rid of the problem, right? When I plug in 0 for that h, that's when we have an icky spot, right? Dividing by 0. So this is going to become negative 3 divided by x times x plus h. Right, but that's just the difference quotient. I want the limit of that as h approaches 0. So the limit of negative 3 over x times x plus h as h approaches 0. Well, now there's absolutely no problem with just doing direct substitution here, plugging in 0. So that's going to become negative 3 over. Plugging in a 0 for h, that means this right here, x times x, would be x squared. And that's it.